All right, I am back. Welcome to the stream, everyone. Or, since nobody is watching right now, to the YouTube video later or the VOD later. We are working on our Atari 2600 emulator in Rust. We are calling it Stanley. Um, I don't think I explained the joke there before. Stella and Stanley are both characters in the musical A Streetcar Named Desire. Stella was the code name for the Atari originally, and in fact, let me pull it up. Um, and in fact, the Programmer's Guide written in 1979 for the Atari 2600 is called the Stella Programmer's Guide. The emulator written in C that is cross-platform, which is also an awesome emulator, is called Stella. So we're calling ours Stanley. Unfortunately, I don't know too much more about a streetcar named Desire, so I can't tell you much more about that joke. But yeah, it's also want to set out the goals here for this stream and for this general project is to learn a little bit more about emulators and for me to sort of level up my understanding of Rust. I wrote a couple of projects, relatively large projects in Rust before, but they were sort of on the web dev side. And I was focused more on making things work and not necessarily on understanding everything about how the language works. And so I would say that I am an advanced beginner at Rust, and so you'll see me struggling and looking stuff up and trying to understand why the borrow checker hates me. Um, Go check out the VODs in my linked YouTube channel to see part one of this. Today we are going to work on memory layout. I got to the point yesterday where I needed to do a jump, and so instead of reading instructions from a file directly, let me actually get into that code like I am now. Let's see where I'm reading this file into bytes and just iterating over the bytes one at a time, pulling them off. I'm going to need to do a bit of a refactor where I load these into memory. Uh, an important thing to note, let's see if the programmer's guide has anything about it. Um, Hold on, I'm going to check to see how this music is doing. It's going to be a little wild for a second. That was already muted. I may have been getting some echo. Or maybe Twitch is better than that. Anyway, on to this. I'm just going to assume the music is fine unless anybody comes and tells me different. It shouldn't be in the VOD or the YouTube video. So anyway, we were getting to the point where we were going through instructions and we needed to do a jump. I think it's the next run. Yeah, the next instruction here was D0, and when we did a quick search for, nope, wrong button, for D0, we get to a branch instruction, which is actually kind of interesting because we're going to need to implement flags uh, as well as like a program counter and program memory. So let me see. I think the Stella guide has a bit about the memory layout of the thing. Let's see. It's talking about the TIA, PIA. Let's see. TIA memory. Might not have anything. I may need to go look up a different sort of diagram of the memory of the Atari 2600. Let's see. 2600 memory. Yeah, layout. Let's go with layout. This looks good. Memory architecture. Where is this from? Oh, it's from, yeah. There's a bunch of like great resources that look like they're from the 90s on the Atari 2600. A lot of them actually are from like the early 2000s and stuff like that. Um, so let's see. Uh, all right. So this says that so in the Atari, the memory is a flat map. The program, which is the ROM, RAM, various like registers that are memory mapped. Kind of all of that live in the same address space, which, as we were just reading and we came across last time, is only 13 bits. The 6502 had 16-bit addressing, but to save a little bit of money, the Atari used a modified version called the 6507, which could only address 13 bits of memory. And in fact, if you set the higher bit for an absolute jump, it'll just ignore those top ones. There's probably some crazy, um, tricks that Atari 2600 programmers used with that, like storing stuff in those upper bits or something like that. There's a lot of crazy hacks that I don't know super well. Um, but this, so the address range from 0 to 7F are TIA, which is the television interface adapter registers. Um, RAM is insanely small. It's from 80 to FF, which is like 256 bytes of RAM, which is shared with the stack, I believe. Um, Riot registers, I'm not entirely sure I remember what the Riot is, although I think that's to do with input output. So I think that's like your controllers, your audio, all of that. Uh, Stuff is handled differently. And then the program memory starts at hexadecimal 1000 and goes through hexadecimal up through and not including hexadecimal 2000. And so that's all of the program memory we're going to have. I've been thinking about this on our time off, and I have been um, considering how to manage this, and I think my first attempt is going to be to uh, hold the ROM buffer separate of like the RAM and Riot and TIA registers, all of those in separate things, and then sort of do the routing when things are addressed rather than putting them all in line, because it was I'm actually not sure how it would fault, but it was a an error to attempt to write to, and it may not even be possible to attempt to write to the ROM. Um, so I think that's what we're gonna do. Yeah, and so let me just quickly go through what I've done already, and the idea behind what I'm doing for now. So for now, for the beginning, I was assuming that the instructions were all sequentially operated, and then consuming them as an iterator um, here, and then basically just matching on the instructions. Each instruction on the 6502 has a different width. Um, we are currently ignoring timing. Um, and right now we have just loading an X register, loading the accumulator register, which is A. storing whatever's in the accumulator. That's why we implemented memory, and incrementing x. But the next instruction we have is the one that is D0, which is one of the jump instructions. And that requires us to have random access to our program memory and not consume it as we go, because there's no way to wind back this instruction. So the good thing to know is that yeah, you're gonna see my lack of ability to do let's see, decimal to hex to do math in my head. So we're going to go from hexadecimal to decimal, and we're going to enter. Doesn't like that, so we're going to do 2. Wait, sorry, I want to go from hexadecimal to decimal. Right, there we go. And I want to enter 2000. It's 8192, which is what I have here. That's the entire addressable range of the 6507. So instead of that, I think we're gonna do. We'll do all the other ones separately, but we'll map memory to its own place. But we're just gonna start at. So what is 1000 convert 4096? So we're gonna add a member of our structure. We're just gonna say program. So U8 as normal, and it is 4092. All right. Let me make sure that I'm doing my math 96. I feel like this is a good skill to learn. Maybe we will learn it as we go here. All right. So we're going to have to change a lot of what we're doing. We're going to go with a little bit of compiler-driven development as we go. I'll deal with the memory later. I don't think anything will break yet, but we'll want to change that a little bit. All right, so I got a byte vec. So the program can be. Let's actually take a look at that. Tic-tac-toe, Ben. ls.la. So 4 kilobytes is the maximum amount for a Atari 2600 program, but I don't think it will automatically be that large unless the assembler does something interesting. So, which it does apparently. Okay, so then I don't have to worry about are all valid. Okay, well we have an n of 1, so let's assume that my home rolled tic-tac-toe.bin is the only option, and that we know that it will be exactly the right size, so we don't have to do any resizing of our vector when we stick it into the struct. So we're here. We have our program. All right, so we have a vector here, and we don't have to turn it into an iterator. We just need to program, and we'll take a. Now, actually, can I? I might not be able to do this. Let's see what happens when I do this. When I take, a reference to bytevec. It's saying it's mismatch types. So this is where I'm going to look at the Cinder library. If I can get my buttons right. All right. Hey, Uncle Scientist. I haven't really said much in your chat, but I have watched you code a couple times. I saw you read Togglebit a little bit ago. Are you done streaming for the day, or are you gonna get back on? Yeah, I lurk around most of the Rust streams that are on sort of during the times I'm online, so that's I definitely recognize you. Yeah, yeah. Uh, I've actually found this is my second stream ever, and I found that like a couple hours of streaming is like a really nice break from work, and yeah, and I get to work on my pet project and talk to all the lovely people of Twitch. Yeah, I think last stream I had Togglebit sort of prodding people from his Discord to come watch, so I had like 7 streamers. This may be a 2 viewer stream, so feel free to. I mean, I think you know Russ pretty well, but feel free to ask questions about the. No, yeah, I don't remember the term for the uh, for for each bit of hardware emulating. I am roughly going to emulate the chip. I think I'm going to abstract the TIA almost completely. I'm not going to worry about how that's built. I respect and think that it would be a fun project at some point to like really do a like full emulation of the of the hardware for one of these, but I'm gonna see if I can get something working just emulating the like behavior, especially on those like related like I'd have to dig into like the wiring diagram of the TIA to understand like what that's doing. That's the like television interface, and that's like notoriously difficult to deal with. Um, yeah, if you happen to know off the top of your head, I'm gonna look at this documentation and see if there's a good way to get a vec into a owned slice. Um, maybe there's like to owned. That seems like a its own data. Turns out I didn't need to look at my documentation at all. Nope, I did. I lied to myself here. Found reference. Maybe I don't know. All right, I'm gonna dig through the brush docs. So let's go vector. Okay, yeah, I'm gonna. Why am I having trouble finding the vector here? What? Why is the search being like this? I wonder. Vec. Oh, because it's vec. Because I said the whole thing out. Yeah, cloning my way out of situations is I do a lot. So let's see. Um, so I know there's like slicing a vector. Oh yeah, what's the delay here? Let me do a quick check. That was quite long. I wonder if there's anything I can do on my side. I'm still getting my setup working. If you have any tips, I'm at 30. I'm at 30 frames per second, and everything like that, I believe. So, um, oh, I guess I dropped a few frames. Hopefully, it'll work itself out. Who knows? Um, Well, I'm just going to keep going. Hopefully the delay gets better. I am resisting stringing Ethernet cable all the way through the house, but it may be inevitable. So, yeah. Anyway, okay. So I was looking at the documentation for vector, and it's talking about slicing. So if that can be mutable, then read only object. To slice use. Okay. Can I just take a? So what is it saying? It's saying. So if I did do not, it would require a lot more work. But if I did take this as a reference, I think that would actually work. Like a tick A. Tick A. Did I put that in the right place? That's the question. All right. So then it's like. Maybe it doesn't like that it's sized. Uh, hey, how's it going? Ammo Khaki 72. Yeah, I'll just give the spiel here. I'm working on an Atari 2600 emulator in Rust. The primary goal to be to like right now I'm working on a Atari 2600 home rolled project that I worked on like a number of years ago. That's good to hear that you're doing good. Um, and I am trying to uh, so it's the software or it's okay. Um, yeah, it's the hardware, like gaming hardware that I know the most about, and it's actually like relatively simple. Although like there's some like weird stuff about it. So I'm basically taking that binary that I built and iterating through it, and operating on those instructions as we go. And basically, I got to the point where we needed to do a jump. Um, and I had been just iterating through like the raw bytes um, coming from the file, and I need random access now. So I'm making the program part of um, yeah, I'm making the program part of this 6502 emulator. Um, so right now it's saying that I expected a reference to a U8 4096, and I got a reference to a vector. I think that my problem here is that I sized it, and it doesn't like that. Cannot borrow is mutable because it's also borrowed as mutable, but I don't actually need it to be mutable anymore. I would like that to be sized, so I'm like curious if there's a way I can do that, but I may just go to the next thing. Yeah. Um, yeah, I'm gonna do my embarrassing but sometimes helpful rest vec to sized slice owned. Let's see if that comes up with anything. How do I get a slice of vec t in rust? Is there a good way to convert a try into. I don't think this is what I want. It does say take a vector, try into, unwrap or else. Try and do a slides of the type for that. Okay. Maybe that'll work actually. So if I go back and I make this a, let's see. Ooh, yeah. Let me look at the documentation for as sliced. As sliced. Let's unpack. All right, extract a slice containing the entire vector. I think the problem is going to be that fact that I want it to be strictly sized. But let's see what happens when I do that. Just because I haven't been able to hear it, how's the music level compared to the voice level? Is it acceptable, or should I adjust something? Oh my god. Yeah, right. So it's the size. So I think I can do a try into, and then that's gonna say it's a result. Yeah. So then I can just unwrap that. Does unwrap take a? How about we actually expect and say program expected to be 96 uh, bytes was not, and I won't worry about telling them what exactly it was yet. I think it's gonna yell at me as the mute and get rid of the bytes. And I think that actually worked for us because it's complaining about this. All right. Let's see if I can see what I think the program counter is just initialized to be at the address of the program, which is actually let's put this here. Address range is 0x 1002 0x2000. I believe the program counter is just set to 1000 by default, but let's check the documentation and make sure. I've had a couple new joiners. I can give the whole spiel again. 6502 starts in FFFE, and that's in the ROM. I don't. Is that right? That might be right. Let me just double check. So I was going on this, where the ROM starts at 1000, which is 4096. But oh, come on. So we're gonna program like counter. I'm not sure what it'd be called, but I think I can actually take a look at something else that'll let me know. Tic-tac-toe. This is the program I wrote, and I think if we go to source, maybe it's actually includes. Yeah, VHS. This is like a header file basically that slash like setup file for the Atari 2600 that um, that sort of sets up where everything is. So yeah, so there's like base addresses, uh, all that stuff. Maybe that's not where it is. Let's see. Let's see. So all right, I'm gonna do my old-fashioned Google search for it. 6502 program counter. Oh, I see. The program counter is at FFFE. That's right. Um, but what is it initialized to is the question. 6502 has one program counter. It's 16 bits wide because a lot of other things in the CPU are. Yes, I believe that what you're saying is the program counter is at FFFE and probably FFFF. Um, but we don't have to worry too much about that. I think we can just abstract that and use 6502 per counter initial value. Yeah, okay, so and load the program counter. Um, we'll get loaded with 1,000. The execution will start there. However, most 6502 systems contain a ROM in the upper address region, uh, point to a location there. Okay, but on the Atari 2600, it's at 1,000. So we can just, or hex 1,000. So we can just start it there. It'll be interesting to see what addresses we're trying to jump to here. Um, so we'll just call this PC. Um, that's actually it could be just a U16. And then actually let's move that around. We may run into problems with this later, but we will see. So and we'll set that to all right. So the interesting thing that we're going to have to do here in a second is translate between the program counter and our sort of we're going to basically offset, which I think shouldn't be too hard. If we offset by 1,000, I'm thinking like we could do something fancy and like implement index for our own type eventually, which I've done before. That would read that as offset. But I think for now, all the addresses can just be. Yeah, let's just see if we can get this to work. So this should look like, let's say, we'll actually just call it instruction equal, just instead of the next byte, we're going to do chip dot program, and we're going to offset it by the program counter, minus 1,000, not 0. So currently gotta spell it right. Yeah. So currently we're using the iterator to sort of pull off the next bytes, but we may need to increment the program counter, right? Which is going to be. Oh, all of this I can pull into other. I can make abstractions for later. I want to see those abstractions sort of build themselves. So that didn't make a lot of sense. I want to see like where the pain points are so that those abstractions make themselves clear rather than trying to think too far ahead of it. Could not be indexed by. Yeah, that's annoying, but that's why I was thinking. Another reason why I was thinking of implementing index, because then I could have it indexed by a U16, but we can as usize. I gotta spell it right in both places. Is the key. So we're gonna do a chip dot PC, and it's gonna. I think that's gonna be a pain point eventually, is because I'm gonna be doing this sort of everywhere that I pull an instruction to be a good candidate for a method. So instead of this, args is going to be. We'll let we'll let the indexing change or panic here instead of panicking on our own. So we'll do. We're going to be doing this a lot. Program. I think that this pain may become apparent. Let me get this working, and then I think I will refactor this. Chip.pc minus. What doesn't I like here? Oh, now I don't have to do reference anymore because it's not borrowed. So we're just going to copy this over. That actually just increments the checks. so that should all work as expected. Um, Let me T to be cargo run CR. And so then when I unknown instruction 0. Oh right, because I'm not incrementing the program counter, which is exactly what I was saying was going to be annoying. Already is annoying. So for now, and then I just quit them. Don't ever say you can't quit them because you do it accidentally all the time. Fat finger to quit. Alright, so then I need to remap my key. Alright, so that's the instruction that I was actually expecting to come up next. That's the branch instruction. So I'm going to go ahead and quit out of it. Actually, I'll just leave it down there for now. In fact, if I run this again while I open a new terminal, I need to mess around with how this stuff's run. My Vim setup is in dire need of some attention, but we will get there. All right, cool. Yeah, okay. So I think I'm going to implement. Not going to worry about implementing index yet. I'm just going to implement a function that gets the next instruction and increments the program counter for our struct. So two. So we're gonna do what is it? Next instruction. Actually, because not all of them are instructions, so we're just pulling them off byte at a time. So I'll take. This needs to be a mute self. I think that's it. And then it's going to return a U8. And then we're going to do basically what we're doing here. I don't know if you're still around, Uncle Scientist, but what have you been working on recently? It's not being so we can do the roguelite tutorial on Monday. That's awesome. Yeah, I'm like my memory is like a bit fuzzy, but I feel like yeah, no, I feel like you're working on a roguelite in Rust, right? Is that am I remembering correctly? That's all, my memory plus you jogging it. Um, I think I think that's really cool. When I first picked up Rust, like when it first came out, somebody had like a tutorial. Maybe this is the one you're talking about, and it was like dead at the time. I'm wondering if are you saying like somebody picked it back up and like refreshed it because it was really cool. It was like it seemed like a really good introduction to Rust and like to like roguelike games and stuff like that. I was sad when like it didn't compile for the most part. I feel like I'm really delayed now. Let me look at something real quick. Not really dropping frames. Yeah, I think I'm gonna have to bite the bullet and string. It wasn't too bad. Yeah, yeah, I thought so. Yeah, maybe he's picked it back up with Rust getting more popular and stuff. But like back in 2016, I think I went to try and go through it, and like it was weird because I was brand new to Rust, and like I also like was trying this tutorial, and I was like having to having to figure out the tutorial and sort of debug all the compiler errors at the same time, which is a lot. But that's cool that it's still working. Yeah. Do you have any projects in mind, or are you just gonna like kind of wing it? I was I just picked something that like I probably wouldn't do if I wasn't streaming it, um, and was like that'll be fun to do, and it'll be fun to be on stream. Yeah. So cool. I think I did all that correctly. If I did all that correctly, it should still run and give me that next instruction. Nope, something went wrong. I may have. Self.pc. Right. I got it. I was trying to be smart. I'm not as smart as I think I am. Let byte equals. Just do this. You got a little while till this year's advent of code, I guess. Or are you gonna go back and do a former one? I always like go into Advent and Code with the intention of like really getting through them, and I get it through about 10, and then I realize like I'm spending as much time doing Advent of Codes as I am like at work or like with my kid. Um, then I give up on them. I feel like I want to do Advent of Codes like on my own schedule, like years after the fact. I also want. I was doing it in Haskell, so I was like trying to be really or like functional about it, and I like that got me up to a point, and then eventually I was just like I want to like never stream them. Yeah. Oh, that's nice. Do you have VODs of the ones you streamed sitting somewhere? But yeah, and then like I got to the point where I was like, I just really want a for loop, and I want to like I know how to do this if I can just be imperative about it, and Haskell wouldn't let me. Um, so I think next time I might do it in like Rust or even like something fun like Zig or whatever. Oh, nice. Feel free to link that YouTube in the chat. I'll go check it out. So I think I fixed that last problem. Yeah, okay, so now I'm in instruction D0. Oh yeah, that guy, and he like he does it with he does it with like doing all the modeling of like implementing like data types and or data classes and stuff like that, and like or type classes or whatever it is, and like trying to like make it a domain model, which is like I really appreciate. But like my functional programming comes from my days of doing Ruby, where like functional is like kind of you can do a lot of functional stuff. So I know how to like sort of deal with lists and manipulate data and like do like reduces and all that stuff. But like there's definitely a limit, and like sometimes Haskell just like I can't solve the problem with that stuff. I just want to I just want a for loop. I'm gonna bookmark this. Bookmarking your YouTube for later. All right, cool. So let's see. We did that. We're getting the next byte. That's probably good enough. Um, I could be really clever about like implementing index for programs, so I don't have to do this as use size. But I think I'm just going to leave it at that. And we're going to try and implement our jump, which will be an interesting exercise. So let's move over to that. Actually, getting good habits. I have a weird thing that I do with my fingers sometimes that makes me save a file called two, and I don't know what it is. I've never figured it out, but it pops up occasionally. Okay, so we're gonna. So what are we gonna call this? We're gonna say refactor to program counter and buffer. It's close enough. Push that. I thought I'd fix this, but apparently I did not. So I will deal with that off stream. I'm working on Windows subsystem for Linux because my PC that is capable of streaming most easily is a Windows machine. And so there's like some weird stuff where I like set up my SSH agent and that's yes. Thank you for solving it. Of course, the two is right above the W. I'm just fat fingering the two when I write that. That mystery solved. Have you done that yourself, or did you just like sort of figure it out on the fly? Because I'm embarrassed at how long I haven't realized that that's what's going on. Okay, cool. So the next thing we're going to do is handle that instruction D8, and we'll sort of look at the documentation for it. Alt tab. We don't need this anymore. Don't need this anymore. Probably need that because I'm bad at that. At hexadecimal math. Wow. That totally makes sense. Yeah, I'm just hitting the two when I hit W at the same time. It's amazing. All right, it's this one. So we're gonna go for D0. These are branch instructions. Um, so so there's some stuff that happens here. I may need to copy over from the other one I did, but this is BNE, so this is branch not equal. I can talk about what's going on here. Actually, I can show what's going on here. by going into my tic-tac-toe source. I think it's not intro. I think it's tic-tac-toe. I think that's the main one. Processor 6502. It includes Okay. Some variables. It's been a long time since I wrote this. Previous choice state. Reset. Clear all RAM registers. Actually, this is the code we're going through. So we've handled load X. We've handled load A, loading the immediate value zeros into each. We're storing 0 with an offset of x here, incrementing x's, and then x, and then going back to the clear label. This is my yeah. You have to set your own stack pointer. It's kind of wild. Um, so I'm trying to remember exactly how this works. So BNE is it branches if the branch on not equal, which I think not equal is the register. Let's see if there's a there should be some register stuff here. All right, well, let's figure out what it's doing. Um, yeah, that's what I'm thinking it does too. I think it checks for the 0 flag, and if it's not 0, then it. I just don't remember which way around it is. We can probably figure this out by implementing it. Yeah, thanks for the input. But everything inks. Oh, this is like a little clever hack, right? With it. So you can. That's right. So if it is 0, it branches to clear. No, if it's not 0, it branches to clear. So we're incrementing x. Where it's not 0, so we're branching here. Basically, x is a byte, and will roll over at 256 to 0. So basically, we're saying everything. Uh, this is clearing out RAM and all the TIA registers. There's also setting a segment here, so like we'll see the addresses a little bit later. Will be all be offset by F. Maybe I might be wrong about that. We'll see. But basically, when it rolls back around, then it moves on. So it just sets 0 to those 256 bytes at the starting point. Um, so we're going to have to do two things. We're going to have to deal with flags, and we're going to have to deal with branching. So I said we're going to work on branching, but we're actually going to work on flags, and I have the flags um, that are set here for each of these, and we're just going to have to kind of deal with that. So let's see. Let's do a section here that's like flags. Z 0. Call it Z because that's what they call it. And this is a. This is a. I think this is a Boolean, but I think that if I'm correct, I don't think that like Rust will do anything about like space saving here. So So it doesn't matter if it's a Boolean or something else, but I think Boolean might be the easiest to understand. I think that models the domain better, but we'll see. All right, so, and then actually I'm gonna. So after the match, I'm actually just gonna do a print. Z flag is chip. I think I'm going to have some compile errors because I need to initialize. A lot of this is begging to be refactored, so we'll get to that as we get there. Right. Fall. Uncle Scientist, have you done any 6502 programming before? Okay, yeah. So the flag is set false, and it's false for every instruction. So we should actually let's do a little bit more. I don't. Do I have instruction anymore? Yeah, I still have instruction. So yeah, it's me not being able to spell again. Instruction. All right. We need to look at this as hex. Yeah. Okay. And we won't worry about the end flag. Don't even remember what that is right now. That'll take some looking up. So our load x, we'll set the 0 flag. I believe. So we can do chip dot z equals arg. Load A does the same thing. Store A doesn't. And then inc x definitely does. I think it would need to be after the increment. So we do chip.x. I think that works. So after A2 it's true. After it stays true. And then we increment x and it's 1, and so that flag is false. So that actually, I think, works for us. And so then we're going to just copy a bunch of stuff over here. B, BN, E. Let's see. I don't know that the branches mess with flags, but let me make sure. D0. Yeah. Doesn't affect any flags. Okay, so we leave the flags alone. I think all of these are. These are interesting because if we take the branch, it's a different number of cycles, and it's like it matters if you cross a page boundary. We're not worried about timing yet, but we will be eventually. So we'll need to like, let's see. There's no always instruction. Blah blah blah. All branches have a length of 2 bytes. Where the next one is the label to jump to. That totally makes sense. So we'll need to pull that off. Um, branch branch not taken requires 2 machine cycles. If add 1 if the branch is taken, and add 1 more if the branch crosses a page boundary. If uh, so, that's the pages are the defined by the upper byte of the program counter address, just addressing in general. You can address with a single byte, and that is within the same page, or you can address with an absolute byte or with an absolute value, and that the assembler will figure that out for you. But that'll be a different instruction, and it will. Actually, is it a different instruction? It might not be a different instruction in this case. But that'll actually take a different number of cycles. So this timing was pretty simple for incrementing things, storing things, all that stuff. But it's 2 plus 1 if taken, and then plus 1 if across page boundary. So this is actually like something you have to like organize your data in ways that you wouldn't like completely mess up your timing, because the timing was so important to Atari 2600 development. So D0 BNE. Okay, so in that case, what we're going to do is we're going to take the next arg, and I'm just going to take a look at it. So we're going to do the same thing. Let me just. I'm just getting one more byte. I'm unsure how I would change the page. This is all just sort of memories I don't have anymore. So println. Okay. False. On instruction 9A. What happened there? Did I not? Maybe I didn't save it. Hold on, I need to change my little shortcut there. Oh, right, it doesn't know what X is. I want right. Then I think I need... Watching me struggle with mappings. Cool. On stream today, struggle with mappings. I still didn't do it, but there we go. And then if I do this, I totally messed it up. There it goes. Okay. So I got instructions to 0, but I didn't get my output that I expected. You're supposed to panic. Okay, so I'm getting there, but I'm not getting to... Am I just not reading it right? Ah, okay, it's before the instruction. That's right. Okay. Is FB. Alright, so FB is... It's a little surprising. FB. Let me take a look at that. It's decimal number 251. I shouldn't be anywhere near that in the program, in the program stack. So, am I looking like? Does it need to be 2 bytes? Let's see. All branches are relative and have a length of 2 bytes. See the notes on the program counter for more on displacements. Oh, I think I'm branching. I get it. I get it. I'm not branching on that instruction or where that goes. So that actually goes after the branch is done. Um, Still a little surprising the address there. I think there might be something about paging that I'm not taking into account. But we'll see as I go. Because I only have 1 byte, so I should only have... many addresses. I don't worry about it too much. I will actually do this how we were supposed to do it and see if it works properly. So, actually, no. I'm wrong. So branch is taken. Branch not equal. It should be false. So I'm gonna have to jump to that address. Um, let's go ahead and see what's at that address in the program. So chip dot program. It's gonna be like... we're gonna go with... I think my assumption here is wrong. see, let jump to equals this chip.program. And so we're going to say change to curly brace, and we're going to say jumping to address. Let's put this where it makes more sense. Jump to address, jump to, this needs to be as u size. Does not like this. Oh, right. I don't need to. Thank you, Russ, for being so helpful. Alright, so the next thing we had was 9A, and it didn't know what to do with that. So, jumping to address 85. Did I not do it with? No, that is. Let me think about this. Am I doing this right? I'm getting the arg, which is the address to jump to. Oh. And it's like, what is the... Yeah, I would actually expect it to go back to address 0. Why is that? I'm sure it's something to do with paging. Address to jump to 251. Jump to address 251. So let me take a look at that. So I shouldn't be 0, but it should be... This is 2 bytes. This is 2 bytes. So it should be 4 bytes, and instead it's 250. Probably just misunderstanding how the branches work. Make it make sense. Displacement. All branches are relative mode and have a length of 2 bytes. And displacements. So it's relative. So it's actually an underflow. Okay, so if I do this as... so if I do... as... So it says address to jump to go back 5 bytes. Okay, so let's see if that actually like jives with our understanding of what's going on. So from the label clear, we have one store A is 2 wide. So that's 1, 2, 3, 4, 5. Yes. Okay. All right. So that was my misunderstanding. I assume the assembler just made everything absolute, but it does not. It is actually a displacement relative to the current instruction. Uh, so what we need to do is take this arg as I8, and then we need to change the program counter, which should be let chip dot pc. I think plus equals will work just fine here. To a U16, that's fine. Actually, I think it'll be safe to just go ahead and convert this to an I. It doesn't want I16, so who's managed type U16? That doesn't. Do I really have to check if it's negative, or is there just some way to do that? I've never run into this before. Delta. Select current delta. Wrapping add. That's what I need. Okay. I think I don't need to. These are okay. So wrapping add. Wrapping module. Right hand side. Wrapping around the boundary for the type. So yeah, I think that's what we need. So let's see if I have my program counters currently. That might not work because my program counter I have is an I16, so it won't wrap properly. So I kind of want to. It's a note for myself to figure this out eventually, but right now we can do. So it's an I8. Arg is negative. Yeah, I won't go ahead and look up all the semantics of how to. Chip. I'm still going to need to figure out what to do with this. So if it's negative, then oh man, this is where my it's going to get me. to U16. How do I add a signed integer to an unsigned integer? U16 negative. Okay, so it is wrapping add. That makes sense, right? So we just need to size it the same way, and then the wrapping add will work fine. So this should be an I16. Rest does make it easy, but you have to know what you're doing, which I don't. So that is fun. I'm learning. All right, so then we're gonna do a wrapping chip dot PC dot wrapping add wrapping around the boundary of the type if necessary. Okay, so wrapping add arg. Okay, so that should. Expected U16 founded. Found. So I think I can actually do this as a. This is not a mutation, so I need to do a chip dot PC equals that, and then so let's see. This is offset to jump to, and then we're gonna do. Then we're gonna just print out our PC just to make sure that it's sane. So PC. So that's fine. This won't look right. So we'll just do that in hex. I think it'll make more sense because otherwise it'll just look like a big number. All right, and then my program counter is going to be in. Actually, I'll just leave it as U16. No, I'll do it in hex because that'll be again easier to reason about. And then chip dot PC. All right, let's see. Our PC is 1104. That does not seem right. Offset to jump to is. Yeah, because it didn't wrap over the U16. So I need to, like. I think I need to add them the other way. I think I'm. Does that make sense? So the program counter is wrapping add argument. Right. I need. Yeah. I actually need to like subtract the U16 from the. Oh boy. Can I do this as I16? Right. This is all sort of like me not fully like comprehending two's complement. Like I know it exists, but I haven't used it in a while. So I'm like, when I do that byte as an U16, then it's only the lower part of it. Um, so now that I have it as an I16, it's going to say that this arg is mismatched. So if I convert it back to a U16, right, the I16 will have all of the bytes set properly for the wrapping add to work properly. Let's see. That's my conjecture. Let's see if it's right. 1104 is still showing, so I was wrong about that. Let's take a look at what this arg looks like. Oh, we're already looking at it. Let's see what it. So I would expect that arg to be an I-16 in hex that should be 2 bytes long, but it's only 1. I wonder if Rust is doing something. Let's see what the arg is. Not in. Okay, so this as I-16 does not preserve the sign, right? Because if I do it as I-8, oh, there it goes. It's actually working, as you can see. How? What? How did that work? Um, Wild. So I think the thing is I think I need to do wrapping ads for other stuff too because it's not wrapping over the boundary of what I'm doing. So this plus is not working properly. So, but why did that work? So arg as so when I take that I8 and change it to an arg as U16. Uh, Offset arg as U16. Yeah, okay, that looks like a. Yeah, okay, that looks like right. All right, so I magicked my way across the right incantation to get this all to work right. I think the basic deal is that I'm taking it as an I8. Then when I convert that to a U16, yeah, it takes. Let's actually see what that looks like in hex before we move on, so I can be sure I understand what's happening here. Yeah, right. Okay. That is -5 and 2's complement. That totally makes sense. All right, we can move on. So the right now the it's just looping forever, and that is because I don't think that this edition right here is doing a wrapping add. Um, so I think I need to do something similar to what I did up there, which is chip dot wrapping. Actually, I don't think that's correct at all. I think the problem is that I'm never not updating this chip. So basically, or this. So I need to do this if chip dot z doesn't it like this language does not require that. Cool. And otherwise, I'm just going to increment the program counter like I have been. Actually, this will increment the program counter. So if I am correct, we will get to our next instruction, having implemented our branch not equal. This actually needs a label. Let's see if it's a first timer. I don't know how to do. I don't think I have channel points or anything set up, so I can't do a casino. All right, 9A, which is we know is the next instruction. So we actually just implemented. What time is it, by the way? It's 1 o'clock. Let me make sure that I'm. Okay, I actually am going to have to wrap this up real quick. I'm going to make a commit, and I'm going to figure out a raid target for us, and then get going. I have to go to a birthday dinner today, but we did it. We implemented it. So for a recap of what we did, we implemented a couple of things. We implemented the storing the program in memory rather than just iterating through the bytes of the file. We implemented the zero flag, and we added this nice sort of function to get the next byte, which will increment the program counter properly. And all of that was in preparation for branching, which is sort of, I mean, it's key, but it was the sort of next thing that we hadn't dealt with, and sort of next class of things. So we figured out how wrapping adds work, and I don't need this empty else. And it jumps back to wherever this offset is, which is cool. So I'm going to make a commit for that. The repo is in the GitHub linked in the sort of channel description if you want to check it out. Let's take a look at what we did today. So that's adding the flag. We don't need that. Take that. We'll take that. We'll edit this. We don't need that. PNE. Thanks for joining me, everybody, and thank you, Uncle Scientist, for coming in and giving me your various hints. Let me take a look at who is live right now. Back to Twitch. Is Hedgen? Is that Hedgen? No, it's TJDV. Anthony writes code. Actually, why don't we go ahead and raid TJ? TJ underscore DV. Cool. Well, again, thank you for joining me, and I will see you all over on Teach's channel. Do I need?